Okay, so you're asked to calculate the length of this relationship. And I'm looking at, they gave me a picture which is very helpful for me. And I want to just emphasize that I've got points in the picture that are important for me. We'll also talk about symmetry. But there's a point here. I want to point out the point here is 5 comma 0. It certainly satisfies this system, that equation over there. And you can put the other points down too if you want. And this graph is, relatively simple to analyze, all right? So they got other points over here too. Let me just outline these points I'm looking at. This is an important point. This up here is 0, 5 is an important point. This down here is an important point. It's going to be 0, minus 5. And this point over here is going to be, minus 5 comma 0. What I want to emphasize, though, is that the function it's even, it's odd, and it has x-axis symmetry. So what I'm going to do is I'm just going to do one section of it. I'm going to do this section over here. However, they want the length of the entire thing, so if I know that length, I would have to multiply it by 4. So let's go through that. And the first thing I want to do is, talk about the derivative, and let's write that down. It might be difficult. So I'm going to use implicit differentiation. I'm going to write down 2/3 x. I'm going to reduce the power by 1, so that's minus 1/3. Then it's going to be dx. I'm not going to write that down. So what do you get? 2/3 y, reduce that by 1, minus 1/3, and then I get dy dx equals the derivative constant 0. So let's see if we can figure this out. So dy dx equals, let's see, I'd subtract, the 2/3, x to the minus 1/3 from both sides. Let me put that down for you. And then I would divide both sides by 2/3, y to the minus 1/3. I want to simplify that, so dy dx, well, I certainly get a negative, and then what I get y to the 1/3, and then I get x to the 1/3 on bottom. What I'm going to do now, I'm going to square it. So dy dx squared is going to be equal to y to the 2/3 over x to the 2/3. I'm going to write my integration down now. But again, I want to lose sight of what I have to do over here. I want to point out we're just going to do one section, but I'm going to multiply it by 4 because I want all sections, so 4. So remember, I got points over here. We're starting at 0. This is along the x-axis, and stopping at 5. Now, if you're on the exam and you have a tough time with integrations or computation, you write down the integration, of course. Then you come back to it later and do the computation. What's going to be 1 plus y to the 2/3 over x to the 2/3 dx. I realize, someone could look at that and say, I don't think I could do that. Right? Here's the deal. They're not going to give you something you can't do. What I want to do is I want to go through it. There's going to be 4, 0 to 5. It's going to be root. And what do you get there? You get x to the 2/3 plus y to the 2/3. And this is going to be over x to the 2/3. Now, I realize sometimes that looks worse than you started with, but the bottom line is I know something. What do I know? I know x to the 2/3 plus y to the 2/3 is 5 to the 2/3. Let me write that down for you. Again, it's 5 to the 2/3, right? Well, I got to do, I forgot the 4. This is going to be 4, 0 to 5. I'm going to take the root of it now. And between 0 and 5, I'm not too worried about, absolute values at this point. It's a cube root anyway, so I don't have to worry about that. So what do you get? Well, it's going to be, 5 to the 1/3. That's pretty simple. And then it's going to be x to the 1/3 in bottom. Let's write this down. You're going to get 4 times the cube root of 5, 0 to 5, x to the minus 1/3 dx. Well, I got to integrate. Doesn't look that bad. I'm going to increase the exponent by 1. That's 2/3. I'm going to divide by 2/3 and multiply by 3/2. I'm going to evaluate this from 0 to 5. Let's keep going. What are you going to get there? Looks like you get 6. Cube root of 5. And then I'm going to do this evaluation. It's going to be 5 to the 2/3. That means it's going to be a cube root of 5 squared minus the cube root of 0, which is just simply 0. 0 squared, 0. I think I can move on. You can get 6 cube root of 125. Put a box in that. Again, I want to point out, graders are often looking for, an answer. I notice I put an answer down and I could have made it simpler. The cube root of 125 is simply just 5. 6 times 5 is 30. All right? But anyway, let's take a look. Make sure you know that there's milestones to meet over here. One is, getting the derivatives, squaring the derivatives, writing the integration down, evaluating the integration, and getting an answer to it. Now, again, I put this down. The answer is 30, though. In hindsight, the cube root of 125, rather simple, just 5, and 5 times 6 is 30. The problems, although, I want you to pay attention to what they're asking you to do, and make sure you understand that the problems we're giving you are doable. All right? That's really important. Thank you.